This is a flip video about stoichiometry and doing conversions. So it's a continuation of our stoichiometry mole ratio video. So now that you know about mole ratios, let's just review really quickly. As we already learned, a mole ratio is used to change one substance into another. So if I'm talking about a balanced equation, which as you remember, stoichiometry uses balanced equations. And to refresh our memories, the big coefficients in the front are the mole ratios. Remember, we have the invisible one here. We could say we have that many moles of each substance. And we can make a mole ratio with any of them. If I want to compare two different substances, change one substance into another. So maybe aluminum is my one substance. I have 2 moles of it. And I want to know how many moles of hydrogen I have. I have 3 moles. So 2 moles of aluminum produce 3 moles of hydrogen. Okay, that's our review. What's our new thing? Well, now we're going to bring in an old topic, which is mass, and bring back also our mole ratio. So mass and moles with stoichiometry is our new topic. So let's dive in and take a look at a sample problem that's going to involve conversions. And it says, how many grams of aluminum will react to produce 12.0 moles of H2? Again, I'm going between 2 different substances here. Let's identify those substances and circle them. I'm being asked about H2 and aluminum. Now I know that I'm dealing with stoichiometry because stoichiometry talks about going and changing the substance. Changing the substance. Well, in that case, a reaction must be provided for me. So here is my reaction. What we just saw before. So take a second and write this down. Same one we just worked with. Okay. And now let's go ahead and start our problem. I know for a fact somewhere in this problem I'm going to need a mole ratio. And the reason why is because the mole ratio is the only way to change one substance into another substance. Okay? But I also know that in this, I'm starting off with moles of H2, and I want to get to grams of aluminum. Okay. So just like we've done every conversion, you want to start with your given. So let's bring this up here. My given is the 12.0 moles of H2. Don't forget to label everything with a unit and the substance you're talking about. Okay? Next, I'm trying to get to grams of aluminum, and I'm in moles of H2. So the only way to change my substance, if I'm starting with a mole, is to use a mole ratio. Remember, mole ratios change the substance. I want to go from H2 to aluminum. Because I have a mole here, I can write moles of H2 down here. Remember, copy top to bottom. That cancels out. Since I have a mole here on the bottom, I can now do my mole ratio. And I want to switch from H2 to aluminum. Where do I get these numbers for my mole ratio? Hopefully you remember that mole ratios are the moles in front of the balanced equations. So I've got 2 moles of aluminum, that goes here, 2 moles of aluminum, and I look for hydrogen. Make 3 hydrogens, 3 moles of hydrogen, okay? Now, this was our old stuff, which is great, except the problem asks me to do more. It doesn't want me to stop with just moles of aluminum. It asks me how many grams of aluminum. That means I have one more step, okay? Because I need to get to grams. So I know that I can copy this top unit down here. And is there a conversion, you know, that can go from moles of aluminums to now grams of aluminum? Hopefully you remembered from last chapter our conversion. So let's take a second to remember this. We remember that 1 mole is equal to the mass in grams from the periodic table. 1 mole. So I'm going to put 1 mole of aluminum equals the mass in grams of aluminum from the periodic table. So let's get the periodic table out, and let's find our mass of aluminum, right? Here's my periodic table. Here's aluminum. I notice my mass is 26.98. Okay, good. So I put in my 26.98. So this step right here is my old step that I'm incorporating with my new mole ratio. Moles of aluminum and moles of aluminum cancel out, and I'm left with grams of aluminum. So now all I want to do is take my calculator and plug this in. So take a second and do that now. 12 times 2 divided by 3 times 26.98 divided by 1. Always look at your given for sig figs. 1, 2, 3 sig figs. And please write an answer with 3 sig figs. Don't forget the units, grams of aluminum. This is where you need to stop and calculate. All right, good. Let's try another problem. We'll keep the same balanced equation for convenience. And let's take a look at this problem. And it says, how many moles of H2SO4 will react? Here's H2SO4, it's a reactant, with 400 decimal point grams of aluminum. So they want to know how much of this is going to react with this if I start off with 400 grams of this. Okay, so this problem, I'm starting off a little differently. I'm given 400 grams of aluminum. So let's first notice that aluminum is one substance and H2SO4 is another substance. Stoichiometry, changing from one substance to another. How do I do that? Let's take a look. Mole ratio changes one substance into another. Okay, which means that I have to be given a balanced equation, which I gave you. You will always be given a balanced equation with stoichiometry, or you have to balance the equation. Okay, so let's begin with my given. Always start with your given, no matter what. 400 with a decimal point grams of aluminum. And I want to convert 400 grams of aluminum to moles of H2SO4. So I'm starting with grams of aluminum, and I want to convert it to moles of H2SO4. Which means, again, I'm going to need a mole ratio somewhere in here. Well, let's start and see. Can I use a mole ratio right away? Remember, whatever unit's here gets copied down here. Grams of aluminum? I can't use a mole ratio because I don't have moles. And there's no such thing as a gram-gram ratio. There's no such thing as a gram ratio. That might be important to write down. No such thing as a gram ratio. So what's the only thing a gram can go to? This is it. This is the only thing. So I'm bringing back again, once again, that 1 mole equals the mass from the periodic table. So we have to start with our old stuff. So 1 mole of aluminum equals the mass of aluminum. If you remember, our mass of aluminum on the periodic table was 26.98. So I haven't really done stoichiometry yet. I haven't changed the substance. Remember, this conversion does not change the substance. And what I mean by that is, notice I'm still in aluminum, aluminum, aluminum. You cannot change the substance. 1 mole because 1 mole here. I haven't started my stoichiometry yet. That's my next step now. That cancels out with that cancels out with that. Whatever's up here, copy down here. Oh, now I have moles. Can I do a mole ratio? Because I need to change my substance. Yes, I can. I can do a mole of aluminum to a mole of H2SO4. Okay, now I get the coefficients, 2 aluminum and 3 H2SO4. Moles of aluminum, moles of aluminum. Am I done? Let's check. How many moles of H2SO4? Moles of H2SO4. I'm done. This is the part where you need to calculate. Take 400 divided by 26.98, times it by 3 divided by 2. And you should get some answer. Round it to 1, 2, 3 sig figs. Remember, 3 sig figs, because the decimal's present, makes trailing zeros significant. I believe you should get something like 22.2387 moles, which rounds to 22.24 moles of H2SO4. 1, 2, 3, 4. Ooh, no, just kidding. Let's fix that up. 22.2 moles of H2SO4. 1, 2, 3 sig figs to match 3 sig figs. Okay, so for a review, if you remember, in this problem, we didn't start with moles, we started with grams. So I had to use my old conversion, grams to 1 mole equals the mass on the periodic table, not the coefficients from the balanced equation. This is our old conversion. Finally, I had the mole here, so I could do a mole to mole ratio. This didn't allow me to do a mole to mole ratio. Okay? In our previous problem, as a quick review, I started with moles. So down here I could put a mole, so I could have a mole to mole ratio right away.